Hey, my boy.
My man.
Welcome. Unit
5, 6.
5 or 6. Well,
Yeah.
the end of this unit marks the midway point of the year.
Yeah, we'll be halfway done, so we're finishing this before
Right.
midterms.
Right, exactly. So this is the first homework lecture video of that unit called Physical Behavior of Matter.
Yeah, and for those of you watching videos on Christmas break, you rock.
Yeah. Good job.
Yeah, seriously.
This unit's really all about how the matter behaves physically. So there's no chemical reactions.
Nope.
They're all physical changes in physical behavior.
Yeah, matter and energy.
Yeah, how these two get together.
Yeah, but we get to change some definitions for you.
A little bit. Our essential questions, what are they, Mr. Milks?
How does heat change the motion of a particle?
Gotta know about that.
Yeah, this whole heat and temperature thing, we are going to definitely change. We're going to elaborate on some definitions you thought you knew, right? Heat, temperature, motion, and kinetic energy.
We're going to relate them all because they're all very similarly related. And you're going to see the relationships if you don't know them already. Some of this stuff, honestly, 7th grade physical science should be coming back to you in the back of your head going,
When I ask you, if I heat it up, is it going to move faster or slower? I bet you all really know the answer.
So this unit, don't let it scare you because we're just putting new definitions on top of what most of us already know.
Yeah, a little bit of math and we're out of here.
Yeah.
Yep.
How do you measure changes in heat?
Yeah. Physical or chemical changes.
How do you even measure changes in heat?
PBoM calorimeter.
Boom.
Boom. Yeah.
Boiling and vapor pressure. What are those things and how are they related?
Another definition we will change for you. You think you know what boiling is, but you really don't know what boiling is yet.
You don't know a chemist's version of what boiling is.
But you will.
Yes.
We will change your ideas.
And then this one's really important.
Yes.
Are gases predictable?
Yes. Under certain conditions, they are very, very predictable.
If I had hot wings last night, it's very predictable. But I'm joking. No, seriously, like how gas behaves in a container. Is it predictable?
Right. So in our learning targets, you will be able to distinguish between heat and temperature. They are not the same thing. Close, but not the same thing.
Right. And up until this point in your life,
they
probably have been. And at home, the temperature, the thermostat is how much heat's coming on. So to you think they're the same thing, but we chemists distinguish. There's
very much so. Semantics.
Can we convert between units of temperature using an equation on table T? Plug in and chug it.
Yeah, this one's a piece of cake. Stone Temple Pilots is a constant for comparison of behavior of matter. Oh, you don't even know who Stone Temple Pilots are, do you?
The band is not a constant for comparison of behavior of matter.
No, but standard temperature and pressure is.
Is, right. And while you can compare other bands to Stone Temple Pilots, you're not stuck in chemistry world.
One measure for temperature, pressure.
Yes,
I'm sorry.
For comparison.
We had time
to
do it. Yeah, do it.
Can you identify phase changes and how heat relates to those phase changes using a heating and cooling curve?
You guys will get the hang of this. Slants and flats. That's what this
kinetic
one's
and potential.
Yep. Track changes in energy and phase changes for water, physical constants. So this is going to be some more plugging and chugging off a table T.
So basically using that heating and cooling curve to actually calculate heat through the heating and cooling curve.
Yeah, there's 3 different equations.
Yep. All packaged into one area on table T.
Yeah, all of them define Q, which is kind of tough. It's all 3 equations to find the same thing.
You'll see.
You'll get it.
You'll see.
You'll get it.
Understand relationships between vapor pressure and boiling for liquids. So there's a whole reference table dedicated to this, and you need to understand the simplistic nature of what it really is telling you, because you won't be able to figure it out just by looking at it. Generally speaking,
there's some pieces in there you got to figure out, and some practice makes permanent. Understanding changes in heat when dealing with chemical reactions.
Another table.
So
while there aren't actually chemical reactions to study here, other than understanding the change in heat related to a chemical reaction from table I, we're not going to do any chemical reactions.
No, but there's a whole list of this bunch of chemical reactions where it's all written out.
So it's really an interpreting table I.
It's understanding what's going on. Last unit, how to read what a reaction was.
Yeah, it is.
It's going to come in handy.
Understand this kinetic molecular theory. What is it? How does it relate to gases, pressure, and the collisions of atoms that make pressure? Bang, 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 bang. We call it KMT. It is a big theory that is mostly true. I don't know if we put it into a law, but it seems to be mostly true so far.
Yeah, and then what we do is we can play with the conditions to make sure it's like absolutely true.
Right.
So that's what's nice. Behavior of ideal gases. How do gases behave more ideally? There's a set of conditions. You need to know them. And then once we get them behaving ideally, that's when they become predictable.
creating a model in your mind of how the particles in a gas behave is the ideal gas
How he
behavior.
lost all his hair. He kept
Pulling them out, thinking of ideas, tell you.
Yeah, and then we will also use the combined gas law, which is another table T, plug and chug.
Straight up. It's derived from some other more complex, interesting gas laws, if you ask me, but we just have to teach you the simple basics.
Yeah, I like the real deal Holyfield.
I do. Yes.
You know, that's doing too much.
If we could go on our way back machine till 1996,
We would be there.
happy.
All right, so here's your list of assignments for the unit. I see some 1, 2, 3, 2 POGLs.
Yep.
A few labs, some castle learning,
Yep.
some video lectures, and that's it.
The same status quo, right? The same type of assignments. This one is a little longer because the physical behavior matter covers solids, liquids, gases, all of it. So the notes wise are a little longer, but to be honest, those of you who are getting the hang of it are really getting the hang of it. And
I really want to see
doing
this
awesome.
thing checked off all
Appreciate
the way
it. Yeah.
through.
Please use the checklist.
Yeah,
I didn't
I mean,
put it there for my good. I already know what's up.
No.
So use it. If you finished it, check it off. Move on.
Keep track.
Yeah. That's what I want to see with my students. Use the checklist. And I got a Google Classroom assignment.
Yeah, I will hopefully remember to do that for you. Milks has been slipping on his Google Classroom assignments, but nobody's been complaining in my classroom yet.
Well, that's why. Because you're slipping. They're not complaining.
I'm trying to do something right.
I'm complaining.
All right. I'll get there. Hey, thanks for
Peace.
watching. See you. Merry Christmas.
Merry Christmas. End recording.